Alright, so this is your key here, 10 through, I guess it is like 14. We'll start on 10 now. 10, we've got a velocity function. It's what you're given the velocity of the particle, that function. And you're also actually given the acceleration function too. There's acceleration. A says, is the speed of the particle increasing or decreasing at t equals 5.5? Okay, well, let's talk about what it means for speed to be increasing. What it means for speed to be increasing. So we'll make some notes here. Speed. Okay, speed increasing. Speed. So what do we know about speed increasing? We're going to have to reference velocity. Velocity and also acceleration. So let's think, let's say if velocity is positive and acceleration is positive, is speed increasing? Yes, right? Velocity is positive and your acceleration is positive. Your speed is definitely increasing. Okay, one way to think about that, velocity being positive, okay, that means you're moving forward. Okay, so think if you're in a car and velocity is positive, okay, I guess I drew a truck. Sort of a truck. If you're in a car, a truck, and velocity is positive, you're moving that way. Now, just because you're moving that way, right, just because the car's going forward, does that mean that your speed is increasing? Well, you're going to say no. Like, there's plenty of times when I'm in my car, truck, or smart car, whatever, where you're moving forward, but your speed is not increasing. So just because velocity is positive doesn't mean your speed is increasing. Okay, what if I said your velocity is positive and your acceleration is positive? Well, what does that mean for acceleration to be positive? Well, if acceleration is positive, acceleration tells you about change in velocity. Well, if acceleration is positive, your velocity is, I want to say, getting more, is either getting more positive, or velocity is getting less negative. If acceleration is positive, your velocity is either getting more positive or your velocity is getting less negative. Now that's kind of confusing there. Here's another way to think about positive acceleration. Okay, if you are in your car, okay, you sitting in your car, okay, if in your car is okay, you got wheels on your car or something, okay, so we're going here. Well, maybe it's a truck. Evidently you drive a lowrider. Okay, so you're sitting in your car. So if you're ever in a position in your car where you feel yourself getting pushed into the back of your seat, like think about what happens when you get pushed into the back of your seat. Well, a couple things. You're like slamming on the accelerator, right? You're going way fast forward. You're accelerating. Your velocity is getting more positive. Okay? That would be positive acceleration. That pushes you back, right? Now, what about, so that's how you can have positive acceleration going forward, right? That's how you get pushed into the back of your seat going forward. what about if your car was in reverse? So what do you do so that you're pushed into the back of your seat when your car is in reverse? Well, if you put it in reverse and just jam on the accelerator, you're flying back this way. Well, which way is your body moving in the car? Well, your body's going to fall forward, right? You're going to fall into the steering wheel. Okay, that's definitely not positive acceleration, because I said positive acceleration is when you're getting thrown into the back of your seat. Okay, so if you're, so those arrows, that was saying, hey, you're in reverse, your velocity is negative because you're in reverse, and it's getting more negative. Velocity getting more negative. Getting more negative is, we're going to call that negative acceleration. Because when you just stepped on it in reverse, that throws you forward. Okay, that throws you this way. So think, if you think about it like driving a car, and going forward is positive velocity, going backwards is negative velocity. One way to grab acceleration from the whole car scenario is think, where are you getting pushed in your car? Is whatever you're doing pushing you to the back of your seat, or is it making you like lean forward? Okay, so if whatever you do in your car, if that makes you lean forward, you're experiencing negative acceleration. If it makes you lean backwards, you're experiencing positive acceleration. So that's why I kind of went on a side note here, but I say your acceleration is positive if your velocity is getting more positive, or your velocity is getting less negative. So let's make sure we're clear on that. Velocity getting less negative. What's that like in your car? Velocity getting less negative. Getting less negative. So it's negative, but it's getting less negative. So if you're in your car and your velocity is negative but getting less negative, in your car velocity is negative but getting less, so you're going backwards, you're in reverse. Now how are you going to make your velocity less negative? What are you going to do? You're going to step on the gas or the brake? You're going to step on the brake. Well, if you're going in reverse and you step on your brake, that's going to make your negative velocity less negative. Well, where does that push you in your seat? Just think about in your car, step on the accelerator, you're in reverse, and then you put on the brakes. Oh, you should be getting pushed into the back of your seat. That's negative acceleration. Sorry, you're getting pushed into the back of your seat. That's positive acceleration. Okay, so let's go back up to the initial prompt. We wanted to know about when speed is increasing, and in order to know when speed is increasing, we have to know about velocity and acceleration. Okay, so we got a bunch of things, a bunch of different scenarios. Okay, scenario 1: velocity is positive and acceleration is positive. What can you conclude? Is your speed actually increasing? Okay, well, how is speed related to velocity? Well, speed equals the absolute value of velocity. So, I've got velocity is positive becoming more positive. So, the absolute value of velocity is speed. So, in that case, is speed going to be increasing? Yes. If velocity is positive, acceleration is positive, then that means velocity is getting bigger. Okay, velocity is getting bigger in a positive way. So it's like positive, more, positive, more, positive. Yeah, speed is increasing. Okay, that's kind of scenario 1. Now what scenario 2 would be is, well, I should have said this here. Let's say scenario 2 is velocity is positive, acceleration is negative. Okay, what's speed doing? Well, if velocity is positive and acceleration is negative, what's happening to velocity? Well, that would mean negative acceleration. So my car's moving forward, but I'm getting pushed. I'm leaning forward. Okay, my velocity is going down. So what's my speed doing? So if the car's going this way to the right, and it starts to slow down, right? I'll use kind of the length of those arrows to describe the velocity. Well, what's the speed doing? Speed is slowing down. Speed decreasing. Okay, we've got a couple more conditions. What about velocity? Velocity is negative. Velocity is negative. Acceleration positive. Okay, positive acceleration. I'm getting pushed into the back of my seat. So I got my car. That's now just a dot. I'm moving that way. And this is just kind of one way to think about speed and velocity. So your car is in reverse, and acceleration is positive. Which way are you getting pushed in your seat? So think, are you pushing on the brake? Well, if acceleration is positive, your body is going to be falling towards the back of your seat. Well, if you're in reverse, what's going to push you back in your seat? The accelerator or the brake? Well, the brake. So if you're pushing the brake, is there any way your speed is increasing? No. Speed decreasing. And maybe that's a good way to think about it, right? If you're pushing the brake, speed's definitely decreasing. If you're pushing the accelerator, speed's definitely increasing. So if we go back and use that for the last one, this one here in blue, if my velocity is positive, I'm moving forward. So if you're going to have negative acceleration moving forward, okay, car, that's the dot, it's moving forward, and negative acceleration, that's pushed into the steering wheel, right? Your body's going to fall forward. Well, if you're going forward and your body falls forward in your car, you're going to be pressing the accelerator or the brake. Brake, that's why speed was decreasing. Okay, one more condition. Velocity is negative, acceleration is negative. Okay, negative acceleration, that means I'm sitting in the car or truck and I'm getting pushed which way? Well, that means you're leaning forward. Okay, there's the steering wheel. Okay, and you got your wheels here. Okay, so your acceleration is negative. That means you're falling forward, and your velocity is negative. So if you're going that way, and you're gonna fall forward, do you need to step on the gas or the brake? If your answer is the gas, then you're speeding up. If your answer is the brake, then you're slowing down. So, well, I'm in reverse. If I need to fall forward, I'm going to jam on the accelerator and I'll fall forward. That means my speed is going to be increasing. Okay. So, there you go. That's some tips for you on how do I, work with velocity and acceleration and use that to make decisions about what speed is doing. So let me go back to the question now. And that was 10, sorry. 10 said in A, is the speed increasing? Is the speed increasing at 5.5? Okay, well, you have velocity and you have acceleration. So if speed is going to be increasing, that's one of those two conditions out of the four. Okay, so we said speed is increasing. So we can kind of write it again. Speed increasing when v of t greater than 0 and a of t greater than 0, or v of t less than 0. So you're moving to the left. If you're moving to the left, so if you're in reverse and you step on the accelerator, that pushes you forward. So an acceleration is less than 0. So maybe you can come up with a shortcut. One I was just thinking of is if the sign of velocity and acceleration match, speed is increasing. Because look, in this first one, velocity and acceleration are both positive, speed is increasing. In the second one, they're both negative, and speed is increasing as well. Certainly you could memorize it, but might be a good option. So all this talk, and I haven't even answered it. So well, we just need to use these formulas and compute what v of 5.5 is, v of 5.5, and a of 5.5. So at this point, I would grab my calculator, and in my calculator, I'll just see, I see some trig there when I'm taking the AP test. I always need to be in radian mode. So I'm going to go y equals on those equations. So 2 times sine of e raised to the t divided by 4. So in my calculator I went x divided by 4 plus 1. And then acceleration 1/2 times e to the t over 4. I'm going to do x over 4 cosine of e to the t over 4, x over 4. Okay. I'm going to double check my mode that I'm in radian mode, okay? And I'm on my calculator. I wish you could see it. I've got both equations in y equals. I'm going to go to the table. I'm going to go table set. Start at 1, increment by 0.5. Okay, so 5.5. They're both negative. V of 5.5 less than 0. A of 5.5 less than 0. Therefore, speed is increasing. And on the AP test, well, what would it take to be able to justify speed is increasing? You just say this. They're going to assume you have the knowledge behind it. You'll say, hey, velocity is negative, acceleration is negative, therefore speed is increasing. They're not going to say, well, how do you know? How do you know that when velocity is negative and acceleration is negative? You're not going to have to justify that, but you're going to have to list them. Okay, B, find the average velocity of the particle from the time period 0 to 6. Well, do you have a velocity function? Yes, you do. Well, how do I find average value of a function 0 to 6? Well, you go 1 over 6 minus 0 times the integral from 0 to 6 of your velocity function. So I'd use my TI-89, I'd integrate that. Obviously this is what we're typing in right here for your v of t. I've already got that y and y equals, so I can copy it. Calculator So I'm just going to the home screen, and on my T89 I go F3, integrate, put that equation in. I'm going to go comma x, comma 0, comma 6. It's going to give me an answer. Then I need to divide that answer by 6, because you have the 1/6 out front. So I'll take my answer divided by 6, 1.949. Make sure you put units. 1.949. Velocity is, let's see, do they give us about, they say about like feet or time. Particle is moving. That's really weird, because I want to, when I give an average velocity, I want to say like miles per hour or feet per second, and they don't tell me what the units are. I don't know, so I'm going to say 1.949 units per time unit. Okay, C, total distance traveled. Oh, cool. I like C. So you got to know the area underneath velocity tells you about displacement, and then you can kind of rearrange things, and it'll get you total distance. Like if your velocity curve has some positive area and negative area, and you just straight integrate it, from A to B, then that positive and negative will cancel out, so your distance is going to be less than what you actually expect. What I'm getting at here is, let's say that graph right there was your velocity graph. So the area underneath that, well, red in this instance, if you did let's say red is going to be like, let's say 4, and orange was like -2. If you add red and, let's say -1, if you add red and orange, you'll get 3. That's the displacement. What they want is the actual distance. So in that case, you'd say, well, it went 4 units to the right, and then it went 1 unit to the left. So total, it traveled 5 units. So one way to answer a question like part C is to, well, you figure out what section of your graph has positive area, what section has negative, and you make sure they all end up positive. And the other is, if you integrate the absolute value of velocity, you'll always get distance. So I can say that the integral from A to B of the absolute value of velocity equals distance. The integral from A to B of velocity is always equal to displacement. Sometimes distance and displacement are the same. Well, they're the same when velocity is never negative. So the short answer on C, I can erase some of this stuff. The short answer on C is, we'll take you. Man, they hate to erase. The short answer on C is going to be the integral from 0 to 6 of the absolute value of v of t dt, which equals, you can do absolute value on your calculator, so you can integrate that way. So you go F3, integrate. Now you have to put absolute value in here. So on my calculator, I went, I see integrate, parenthesis, and I'm going to go to the catalog and search for ABS. So it goes ABS, parenthesis. I'll type in my v of t, I'll put my parenthesis, and I'll put comma x, comma 0, comma 6. So when I do that, typed it in, my calculator is telling me too many arguments. Oh, probably because I had it typed in wrong. So integrate, try again. Catalog. Alright, integrate the absolute value of my velocity function for x from 0 to 6. Oh, and it's not liking that. So I'm going to pause this video and see if I can get it right, then I'll restart it. Alright, not to worry, we got it figured out. I had forgotten to close the absolute value parenthesis. And when I did, I ended up getting a total distance of 12.573 units. 12.573 units. So that's how to do it in one sweep of your integral. If you didn't have access to your, let's say like the absolute value function, I'll show you how you do that. It's worth talking about. I know you're 25 minutes into this video, but remember your velocity function. Okay, velocity v of t equals 2 sine e to the x over 4. Oh, that's so messy, sorry. E to the x over 4 plus 1. I think that's how it looked. Double check. Scroll back. Okay, the plus 1, it was 2 sine plus 1. Okay, 2 sine of that thing, and then plus 1. I'm just double checking that I typed the last one in. Okay, correct, we got it. So that's your velocity function. Now, it'll be interesting to know I say that, like it's going to be interesting too, but let's say the velocity curve, that function, looks like, let's see, I'm graphing it on my 89 real quick. So it kind of does some funky things. You only want to look at it from 0 to 6. Okay. So from 0 to 6 it goes, kind of starts here. Ish. Down and it ends here, and let's turn that off. Okay, yeah, so that's the graph, and it, like, so you got 0 on the x-axis, and here you got 6, and that was, you know, if this is there's your red, there's your orange. If you just straight integrate from 0 to 6, your answer is going to be, well, it'll let the orange cancel out some of the red, and your answer would pretty much be about that much. Figuring this is going to be the region that cancels out this one. We don't want that to happen if we're talking about total distance. So somehow you got to add the red and the orange. So you need this x value right there. So you can calculate it on your calculator. So I'm going to go math. Calculate a 0, lower bound, upper bound, and lower and upper when you calculate on your calculator don't mean up and down, they mean left and right. Okay, so that's 5.195. 5.195. So if you were going to get total distance out of this guy, you'd go integral from 0 to 5.195 v of t dt plus, okay, well, how do you make that positive? Well, if you know it's going to be negative and you want to make it positive, you just switch the boundaries here. Upper and lower limits of integration, just flip-flop them. So instead of going from 5.195 to 6, you'll switch them. So the 6, you go 6 to 5.195 v of t dt. So So when you type that second integral into your calculator, you can go integral v of t da 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 da, and then you go comma x comma 6 comma 5.195. In the first one, you go integral v of t comma x comma 0 comma 5.195. So yeah, and that'd give you the same answer. Okay, back to 10. We're almost done with 10. The particle changes directions exactly once. Find the position of the particle at that time. Well, we know when the particle changes directions. It's at 5.195. So we got to figure out, well, where is the particle? Well, I'll tell you what. The particle has moved to the right, the red amount right there. So, from time 0 to time 5.195, particle moves to the right. How far? Well, the integral from 0 to 5.195 v of t dt, which equals, okay, integrate my velocity function from x from 0 to 5.195. So that is thinking 12.135 units. 12.135 units. Okay, now that's not your answer though. That's just how far it moves to the right. It wants to know the position of the particle. It's kind of like if I said, hey, your car went 12.135 miles. What does your odometer read? I'd say, well, it depends what it was before I traveled those miles. So where do we start? Okay, they give you, let's see, do they give you the initial position of the particle? Okay, oh, they do. The particle's position, which is the function x sub t, is not explicitly given, but x sub 0 is 2. At time 0, your position is 2. So, to answer D, let's see, the particle started at 2 and it moved to the right. What was that? 12 point, oh, sorry, making me sick. It moved to the right 12.135 units. 2 plus 12.135 equals 14.135. That's the position of the particle at that time. Okay, cool. That was just number 10. Let me see how long this recording is, and we're going to stop it, and I'll make a separate video for the rest. But number 10 is a great problem that deals with, if you're a math teacher, you think number 10 is awesome. It's super cool because it deals with velocity, acceleration, speed, distance, area under velocity, all that cool stuff. So, thanks for watching. You guys are awesome.